is Tejas, and I will take care of the technical aspects of today's presentation. I'd like to cover a few housekeeping points. At the bottom of your screen are a few engagement tools you can use. All the tools are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your slide area or maximize it to full screen by clicking on the arrows in the top right corner. If you have any questions during the webcast, you can submit them to the Q&A tool. We will try to answer these in our Q&A session at the end of the presentations. For the best viewing experience, we recommend using a wired internet connection and closing any programs or internet browser sessions running in the background. If you have any further questions, please let us know through the Q&A box. I would now like to introduce our speaker for today. We have Dr. Ramprasad Ganni, Technical Support Specialist, Agilent Technologies. I would like to thank Dr. Ganni for taking the time out of his busy schedule to be here with us today. Now, I would like to hand it over to Dr. Ganni to proceed with today's presentation.
Thank you, Tejas. Thank you, Tejas. Good afternoon to all of you. Welcome to the Small Parts Big Difference seminar series. And today we are going to discuss about the enhancing our performance within how we do GC supplies. These GC supplies, how impact our analysis, and what is the importance of selecting a right GC supplies for getting a good result. So let us see in today's session that all the parts. So if we see the GC flow path, our sample goes to the inlet. From inlet to we connect the column using a nuts and ferrules and goes to the column, and then column to the detector. It will go. In this complete entire flow path, we need to take care of it as a chromatographer ourselves. HPLC is a little different than this, but in GC we have a lot of consumables which are in part of our analysis in day-to-day operations. So if we look at it, what are the categories we use it? Vials, syringes to introduce the sample, and after that it will go to the inlet. Then we have an inlet parts like septa, gold seals, and ferrules. Of course, after the inlet, in the inlet only, we have another integral part of our analysis is inlet liners. So, and then fittings. What are the connections we are making in the system? How we are connecting a column to the inlet, to the detector, and how we can make it easy. That makes a big difference for us, avoiding a lot of challenges. And of course, the columns, and then finally detector components. So we'll see one by one all these, what are the things which will influence our analysis, how each part plays a major role in our day-to-day analysis. Especially when we are doing any poor inlet flow path from inlet to the detector, what will happen? Majority of times we are seeing the problems which are, peak shape is an issue, or we are seeing as a unwanted peaks, or peak is missing, such kind of issues. This is because of the flow path is not proper, and we see reproducibility issues, tailings, peak tailings, and drop in the response like this peak. And of course, integration is a difficult task for us when we lose the response, and sometimes we see the compounds will be breakdown, and we see as a multiple peaks instead of a one peak, and eventually it leads us to rerun our samples, which is taking our cost, time, and it eventually reduces our lab productivity. That's the reason each one is very important element for our GC analysis. So in this, what will happen if the GC system activity is there? It impacts our cost of the analysis. Of course, the data quality, which is maybe poor because of the active sites in the inlet flow path, or path for the entire GC system or GCMS system. More importantly, determining our peak for the quantitation, and we need a good signal to noise ratio, and we should not have enough separation efficiency lower. So we need a good separation to get a good resolution between the peaks, and of course the retention order need to be proper. Irreversible absorption can be dangerous sometimes, and non-linear calibration causes a lot of issues for us to have a false positive or false negative results. So it will eventually lead us to OYS. Of course, low recovery, which is also a major concern in our GC analysis. And what are the reasons for these things, and which part of our GC system will influencing these kind of problems? So when we look into it, you can see here the GC surface which comes into the contact with the sample or inlet, where you can see in our lab, and then in the inlet we have a liner, gold seal, O-ring, septa, and after that it will goes to the column through the connector. The connector is how we connect using a ferrule and a column nut, and then goes to the column and then go to the detector. So all these are very important. So GC column is one of the largest surface in the system, and inlet liner, which is with glass wool or without glass wool, we are going to use it based on our sample types. So this liner also plays a very important role to get a desired result. And unions, of course, any active metal surfaces are there, then we are going to have a problematic results. Peak tiling, loss of response can happen. And gold seals, however, we are not going to deal with the gold seals as a chromatographer because we don't change it. Generally, service engineer will come and check it and recommend to us to change the gold seal. We don't do to that extent, but as a chromatographer, we good to know that gold seal also is one of the part which will impact our results. And inlet, if we have a backflush technology, that's where CFD technology is an integral part of the backflush. So there we have some metal connections that has to be inert in nature. And of course the detector parts, which are generally goes with the high temperature, exposures to the high temperature in the detector. So the cleanliness and inertness are also important part for getting a good signal. And then tubings, which we use for the diffusion purpose or the backflush technology. And we see one by one in a GC flow path, we need to carry our sample to the system. That's our primary important thing. And the vials and sample containments, we use a different sample containments, vials, screw cap or snap cap or crimp cap, we use it. In GC analysis, majorly we try to use headspace vials for headspace applications where we use a crimp. And even 2 ml also crimp vials will be used for a certain applications where we need a crimping and decrimping. For that purpose, we can use, for uniformity of the crimping, we can use electronic crimper. That would be ideal for us to have a uniformity throughout the vials crimping nature. And in this part, the important thing is the size of the vial, type of the vial, whether an amber or the clear vial based on our sample, and the material, septa material, what we use it. It can withstand for high temperature or not, which can be compatible with my sample or not. This is one of the reason most of the vial caps are PTFE coated, and there are two ways of selecting it. One side PTFE coated, that is the bottom PTFE coated, which is mandatory for all kind of samples, and preferable to have both sides PTFE coating. If our sample is more active in nature, so that there is no reactivity issues or contaminations issues we can encounter. So another important part is after the vials and containments, then the sample will be collected into the syringe and then goes for the injection port. Then where the syringes will have a different needle, and the needle will be connected to the syringe barrel, where we call it as a termination, and barrel, and then this plunge is a fixed part, and then we have inside a plunger. These are the important things, and of course the markings, how much microliter we wanted to inject, what is the total capacity of our syringe. There are different types of needle types, cone and bobette types. You can use it, and for termination, removable termination and fixed termination. So most of the times autosampler syringes will be in a fixed termination, and removable also can be used. And then there is a different lower lock terminations will be available. Those are for the gaseous injection. Those also called as a gas type syringes. So the important parts in the syringe we need to be careful is needle tip, needle gauge, which is also very important, whether it can be able to pierce the septa what we are using. And that is where we need to be select wide septa based on the syringe what we are using also. That is also important thing. And then termination, plunger, strength, and then style of the needle. So generally for a high viscous and high strength septas, we need to have a good gauge to not to bend the needle or the plungers. And viscous samples, we need to be careful about it. And the second important part is after the syringe in the system is the septa. Inlet septa, we need to have septa in a proper place and with a proper conditioning without any contaminations. We generally use a bleed temperature optimized septa, which will be more preferable for the most of the applications, because it will be suitable for most of the application. And we have advanced green long life septas. These are for the little higher temperature purposes and then general purpose septa also. And all these septas, where we are going to introduce the contamination risk. While installing a septa, we need to be careful not to touch these septas with our hands, introduce the contamination from our hand. So that's the reason blister packings are available for Hazelnut. It is not a bottle packing. Ours is like our tablets packing, so that no contamination, cross-contamination will happen. And another important thing, there will be a groove which will help us to guide the syringe needle to pass through this center part. This will help us not to touch the needle into the surfaces or pierce the septa as it goes without any groove. That's the reason the groove is also helps us to guide the syringe needle. And another important part is after the septa, there are ferrules, where graphite ferrules, graphite ferrules, and Westphal ferrules, and ultimetal ferrules are also available. We will see what is the use of each one, as well as a gold seal and washer, which will be recommended by the service engineer. So we don't look into that one much. If still we are having a problem in any one of these areas, then we need to check with the service engineer to check for the gold seal. So most of the times, what will happen? If we select a wrong ferrule, then we have a problem. For example, polyamide graphite or a Westphal graphite ferrule, the upper limit is 350 degrees. So, but because of the Westphal and graphite together, it syncs with the temperature cycles. So because the temperature goes up from, let's say, 50 degrees to 300 degrees centigrade, you over ramping. During that time, it goes up the temperature then comes back. That's the reason polyamide is required retightening, especially when we are using MS detectors or ECD detectors and inlets. We need to retighten it after a certain time, let's say 25 to 30 sample runs. We need to check it once the tightness of it. Otherwise, the shrinking can hamper our result because there will be a leak. Eventually, the peak shape or the response loss will happen. Another is a graphite ferrule, which is high temperature up to 450 degrees centigrade, and it will be good for the FID and NPT detectors, and then of course the inlets. Most of the time we use a graphite in the inlet side. When it comes to the detector MS, then we try to use a Vespel graphite ferrules. And there are metal ferrules which are used for the capillary flow technologies and backflush devices, where we try to connect, let's say, backflush in between intermediate 15 meters one column, another 15 meters is towards the detector side. In between, we connect the device. Those cases, metal ferrules are very important because these will have a leak-free and inert also. That is where gold or multi-metal ferrules will be used. Of course, gold ferrules are the highest inertness, which will help us not to introduce any contaminations, and eventually we will get a good peak shape. And you see here, the flexi metal ferrules, multi-metal or a gold metal ferrules will have some grooves in it, so it reduces the stiffness during the installation, and then it will not allow to break the column if we are over tightening also. That is the one of the reason in CFP technologies it is better to use multi-metal ferrules or a gold-plated ferrules. If my particles or in the sample analytes are polar in nature, I always recommend polar or highly basic in nature, which better is to use a gold-plated ferrules, which will have a good inertness in it without having any problem. And if these are majorly we use in a CFD flow technologies where we use a backflush or connecting a columns together. And gold plated or the ultimetal or even a graphite ferrules or a Vespel graphite ferrules will come in this die packing. You can see all the ferrules will come in this to prevent the contamination by touching other ferrules while taking out from it. That is the reason all the packings will come. You just need to rotate it and collect whatever from that location the ferrule which is required, and then install it, so that other ferrules not in contact with our hand or the tools or even for the environment, so that inertness protects until we open and install. So that is the main reason to have these kind of packings to protect our analysis. And after the ferrules and all, we have a liner, which is a very important part in our analysis. Liner is the major reason for most of the tailing issues, peak tailing issues, along with the connections. Tailing also can cause due to the liner, contamination in the liner, or the degradation in the liner, or analyte might degrade in the liner and carry over due to the accumulation of our sample in the liner from the previous runs. Of course, loss of response also one of the things which could cause by the liner. So what are the key factors influences the analysis part? Inlet liners, deactivation. So if the liner is active in nature, what will happen is any polars or highly polar compounds will try to retain onto the liner surfaces, and then we will eventually get two problems. One is the tailing, another one is carryout. So because of this, eventually we will lose the, because of tailing, of the liner is very important thing. And characteristics, what type of liner, design, and glass core. Whether it is required or not. If it is required, what kind of glass core. In general, if you see, we generally tend to pack a glass wool ourselves into the line. What will happen? It's a glass wool. It will packing time. We have two risks. One is it's a glass wool, so we need to use a protective equipment not to imitate any glass particle into our nose. Otherwise, what will happen? You know very well. Glass particles goes into our body. What is the health issue? Secondly, when we are removing a glass wool from the liner or packing it back, the first and foremost thing is we scratch the glass surface, inner surface, which will create the active surfaces. Once the active surface is formed, then when you are injecting active compounds during the runs, you will see the peak tailing issue or the carryover issue. That means RSD of the area can fall down, or you will see an unknown peak or an extra area in the next run. Those kind of problems. That's the reason it is very important not to create any active surfaces. So preferable you collect pre-packed liners and use it. And the second one is the density. What density we are packing. Instead of having all these problems, better to have it pre-packed glass wool liners for a general purpose. And the wool quality also very important. While packing a wool, this glass can break and create an active surface. That's the reason. So having an ultra-inert feature for this, that is treatment of the surface of a glass wool and a liner together, not to have any active surfaces, that will be ideal liner for most of the application. And the secondly, we may not require a liner all the time, especially for the compounds which are highly active in nature, which can retain anywhere else due to moisture or any other reasons, or highly basic compounds. If the sample is not demanding a glass wool, like if we are using a API bulk or API formulations, in those cases we can directly use without glass wool liner. That would be an ideal thing. And if we are having a samples with a lot of matrices, like food, environmental matrix processor samples, always better to have a glass wool liner. So again, it depends on the application. We need to select a liner, whether with glass wool or without a glass wool, even the shape also. What will happen if we are handling very roughly the liner, glass wool packing, removing or whatever the things, all those contaminants, even a glass wool packing time, what was happening, creating a glass wool particles, it will go and sit into the head. And even samples, you might have seen in your GCMS when their service engineer is doing a preventive maintenance or a maintenance, you see the source is getting contaminated due to matrix. So that is where we need to be carefully choose the liner. And the liners, there are a lot of first one is the deactivation, and then geometry of the liner, where what is the volume of the liner, whether it is a 4 ml or 2 ml capacity of the liner, it depends on the instrument model. You need to select it carefully based on the and another important thing is what is the expansion volume after conversion into the gases. Let's say acetonitrile or methanol, if you inject, each one have a different expansion volume. Is it sufficient, the total volume is sufficient to take care of that volume or not? If that expansion volume of the sample solvent is more than the liner capacity, what will happen? Our results are irreproducible. Especially you might see a area variations run to run. That's the reason that volume should be within the liner volume. And of course, for the the inletness and not to have any active surfaces, and it will eventually help us not to face a tailing or a fronting and area reproducible issues if we can have a inlet liners. So all the inlet liners are highly recommendable for this purpose to avoid majority of the challenges. So here also you can see here there are two. One is low low tapered glass wool liner, which is most commonly you might be using in your lab where the glass wool is fitted here. So, and another one is mid one, which is a splitless, ideal for a basic threads, not the lower one, because it will have a more absorption of the active compounds, more basic compounds with amines and all. Generally, we have a highly active nature. For that purpose, better to use mid single taper liner. And for all the other solvents analysis, VOCs, volatile organic compounds, OCs, OPs, pesticides, lower taper glass wool liner is preferable. And for the you want a same liner, then we have introduced a new liner recently, which is the porous glass centered line. Right. So this can be used for both applications or both the kind of molecule, like VOC analysis or basic threads and all. So this is the new liner, single liner for both the applications. You can utilize this. And most of the time we forget what liner we need to use, or SOP is also not covers this liner concept, but it's a very important part for our analysis. And fittings. When it comes to the fittings, column nuts, CFD devices and all, we need to make sure the required length in the inlet or the detector should be there. If it is more or too less, then eventually you will have a problem of the peak shape. Like you can see here, improper connection can give you a peak tailing and then or a fronting issues based on the compound nature and the resolution phase. That is where GC column installation is little, cautious, need to be maintained while installing. We need to carefully maintain how much length need to be kept open for the access, whether inlet or a detector. And proper installation will give a proper results. Improper installation will not give a proper. For example, in this diagram, you can see here in the bottom left-hand side, the column is, you see, too much goes to the up, then you will have a problem. It is not at all going, focusing into the liner, then what will happen? The sample will be going outside, leakage will happen, that also will be the problem. That is where the length is very important. So we have a tools, and to connect also, most of the times we use it traditionally using a spanner and all. While using a spanner, it will be difficult for some analysts where any touching on the column, it can break the column also because it's a glass capillary. So we use that one, and we use and when we are using a graphite vesicle ferrule, as we discussed, it needs to be retighted. You can see here, initially you will get it like this. After usage of some samples, like after 25 injections of the cycles, injections means it's a cycles, including planktons, I'm talking about it. So because 50 to 200 or 300 degrees centigrade based on your program, it will go and come down and then goes. Like that, after 25, 30 cycles, you will see loss in response and then baseline also not stable. Because a leak due to the shrinking of the ferrule. That is where you need to retight it. When you are encountering such kind of problems, or better to change the ferrule or reconnect it. So, and for a connection, for a traditional way, it is really difficult for us, all the times tightening, retightening, we need to be careful. That is where self-tightening nuts came. nuts will have a grooves, we can do it with our hand and with a collar. So for a collar, what it will help is to hold our capillary column, whatever the length we required it, so that there is no falling below or the size variation during the installation. And then it will help us, we screw it after installing a column to the collar and we install into the system using these wings. So this will be easy. We can do it with a hand also, tightening and or the opening of the nut. Be careful, in hot condition don't touch it, because at the end these all are made up of metals only. So that is the another important thing is, if we over tighten, what will happen? Generally you might have seen with the normal nuts, with the wrenching is too much, then there is a breakage in the column here at a ferro junction. Basically at this junction it will have a breakage. What will happen? We will get a improper peak shapes, so it will eventually affect our results, pigtailing and area issues, and of course a resolution. That is, in this case, when we are using, there is a spring loaded, so even if we are over tightening also, it will not impact on the column breakage. That will help you. So similarly, a metal pebbles also, the design will help us not to break the column in case we over tighten. And self-tightening nuts, you can see here, there is a spring technology, and with a collar, it will help us hold the column whatever the length is we required. And there will be a soft rubber to grip the column so that it will not come back or touch other surfaces and break it. That can be prevented easily, along with easy installation with a hand. We don't require to use a spanners and struggle on. And this is again, even self-tightening nuts of the transfer line with a vesicle graphite or a polyamide graphite, you can see shrinkage issues. So we need to retighten it. This will be also easy when we are using self-tightening nuts, because we can do it with our hand. So this is another thing, at the start and after 300 cycles also, we can get a similar results without any problems and issues in this with this self-tightening. And in case, suppose if you don't want a spring loaded, you wanted to use a normal one, it is also available without a spring, and it can be used without spring also for the inlet or a detector of the FID and regular splitless inlets. You can use this, and for MSD this is the part number, but these will not come with a spring, so that over tightening should not be happening. You need to tighten it just enough. And another important thing is, there is a we use generally ceramic column cutter. Similarly, we have a product which is for the length which is required for the each system, the column length. If you see here, for FID from this point to this point, if it is MMI or SSL, or so based on the type we can see. If it is an MS, this is the length. So we will put here, there is a bruise to hold both the wings like a butterfly wings, and from there it will start, and up to what length we can leave the column to insert it to the inlet or the detector. It will be easy measurement tool, not to guess how much or the scale. Simply directly we can do it. This is one of the useful tool for any chromatographer to install the GC column. And matching correct nut. If you see here, we used to use these kind of inlet nuts for the inlet, and MS purpose this. These are the required tools to install the nuts. Now these comes with a wing nuts, which is without a spring, and a self-tightening nut with a spring, not to have an overtime. Now, what kind of pebbles we are going to use? Generally, for all these short pebbles, graphite vesicle, we are going to use it for the inlet side. When it comes to the MS, For the wing nut, long ferrule, like in a regular long ferrule, if it is a self-tightening nut, we need to use only short ferrule, not the long ferrule. Self-tightening nut for an MS detector, we need to use a short ferrule. So it will be a ready reference for you what kind of nut you are using it, what kind of ferrule we need to use for that particular thing. Most of the times we use a short ferrules for the inlet side, all the inlets, and for the detector side, only for the MS purpose, if we are using self-tightening nut, we need to use again short. Otherwise, if it is a big nut, long ferrule only. And then detector supplies, we have MSD, FID, NC, NPD, ECD, TCD. The legacy FID jets are this, and the new rings actually, jets are, there is no ring. This is standard bore, and if it's a mid bore, you can see here mid bore, there is a one ring. So how we will be able to identify? Here we don't have any thing you can see as an analyst what is this jet and what purpose. So you can see here mid bore, and this is the standard bore, that is 0.53 mm ID, those kind of columns. Wide bore nut will be used where two rings will be there. So the rings will change the bore size. With the two rings, wide bore, mid bore is a single ring, and the standard one is no ring. Like that, MS filament also very important thing for our results. It influences the sensitivity of our MS, so we need to be changed carefully, periodically when it is required. And after all that, why we are talking about this? Because innatness is the major cause for a sensitivity of the instrument, whether are we able to achieve it or not. Because more innate system, more clean and innate system, we can achieve sensitivity up to DPP levels or DPT levels also. That is where everything depends on it. And then, of course, the results, readiness, proper peak shapes, reproducibility will be influenced by the innatness. That is where we are talking about it more. So, what are the innate parts we need to worry? As an analyst, there is an inlet,